let's we get started about how the light shows its duality nature. First of all, here de Broglie, it is the name of a scientist who first here given this theory about this duality nature of a light. And you can see at first here written or here de Broglie theory and here duality, and it tells us that how the light has two nature. That means sometimes it acts as wave, sometimes it acts as light. Here we are going to talk about when they act as a light, when they act as a wave. So here we are going to talk. So first of all, he first assumed at the time of he was doing his thesis, he proposed that the whole the energy in this universe, in a whole universe, energy is in the form of a matter and radiation. Sometimes energy is in a form of matter, sometimes energy is in a form of a radiation. So energy is in a matter of a is in the forms of a matter and the radiation. It was told by this de Broglie first, and then he, according to him, here is written of moving particles behaves sometime as a wave, sometime as a particles. You know that nature you can get to see in a light too. At the time of sun so light coming from the sun, you can see the light sometime act as a wave nature, sometime it act as a particle nature. So here he said that the waves the moving particles sometimes act as a wave, sometimes act as a particle. The waves associated with the moving particles, whatever the waves which are with the moving, which are associated with these moving particles, we call here matter waves or de Broglie waves. And the wavelength associated with this matter waves, whatever the wavelength with this matter waves, we call the de Broglie wavelength. Here obviously, how can we know the light has particle nature? Light has sometime wave nature. Here is obviously we can understand this from the phenomenon of light interference. Interference of a light, interference of this, sorry, diffraction of this light and polarization of the light. These all this phenomenon of a light show the wave nature of a light. This phenomenon tells us that light shows what wave nature. Whereas the phenomenon like photoelectric effect, Compton effect and black body radiation, these phenomenon, one is photoelectric effect, Compton effect and black body radiation, these all phenomenon shows the particle nature of a light, and they tell us that the light has a particle nature. Here how many assumption? Here two assumption, and here are two things. Sometimes light is a wave, sometimes light is a particles. Therefore, we can make a decision. The light exhibit dual nature and the wave particle duality here is explained. Explanation here is about this explanation you can see, and here is when we are going to find de Broglie wavelength, we can use this formula lambda equal to h by p. Here is h is Planck constant. You can see its value is 6.62 into 10 power minus 32 joule per second, and which we call the Planck constant as, and p is linear momentum of a moving particle. So you know the m is mass of a particle and v is velocity. At that time we can get de Broglie wavelength with this formula lambda equal to h by mv. You can see here. And another thing is derivation of the de Broglie wavelength. How they derived this formula here lambda equal to h by mv. He derived, here is given explanation. He used de Broglie used first Einstein mass relation E equal to mc square. You know mc square, and another Planck relation, Planck's quantum theory of radiation, that where E equal to hf was, and when he mixed these two energy and he compared these two energy and had written hf equal to mc square, and you can see f is frequency, so in the place of f we can write c by lambda formula. H is as it is, and you can see here mc square is as same as you can see here. So when you arrange all this, you can see h equal to lambda equal to h by mc. Mc is what? Momentum. Lambda equal to h by p. In this way he, that means de Broglie got new formula which was lambda equal to h by p, and lambda is wavelength of de Broglie wave, which tells us here wavelength, de Broglie wavelength is inversely proportional to 1 by p, that means inversely proportional to the momentum. And when we want to get the relation between kinetic energy and work done, that means de Broglie wavelength of a electron, and again we use this formula, and this is the, the I have written kinetic energy gained by electron must be equal to the work done, that is written from the work energy theorem. This is the theorem of work energy, I have written here. And from that, kinetic energy, as you know, before 1 by 2 mv square, and work done equal to charge into potential difference, and potential difference is capital V. Do not be confused between small v and capital V. Here you should know small v is velocity of a particles, capital V is potential difference. So our aim is to get what the value of small v velocity, which would be here as v equal to under root ev divided e capital V, ev capital V divided m. This is the expression for velocity of a particle, so which is moving, and we can get with the help of this formula what the velocity with it. And another one is what the wavelength with the moving particles. We can use the same formula given by the de Broglie wavelength, that was lambda equal to s by mv. In the place of v, that we have whatever we get this value, we replace this value at here, and when we put, we can get s by under root 2 m ev formula to get the wavelength. So here are given the energy associated with the moving particles. We use this formula to calculate energy associated with the particles. We use this formula small v equal to under root ev by m formula to get the what the velocity particles has. Another one is what the wavelength of the particles. So when we gonna go to find, we use lambda equal to s by under root 2 m ev formula. In this way we can get any moving particles, energy, wavelength, and velocity. Here is whatever described, you can see here in this de Broglie theory, which is about the light or moving particles nature. And as a the sum of all these things, you should understand light exhibit two nature. Sometimes it acts as a well, sometimes it acts as a particles. That is about this de Broglie theory. Thank you.